So I hope you can see this whiteboard screen, right?
Yes, sir.
So we will start with relativity, which is the first unit of the syllabus. Okay. But before we start teaching, let me come back to the MS Teams. And uh, you will also have this kind of, guys, please mute yourself. So in this online system, please make a habit that whenever you are not using a mic, just mute yourself. Okay.
Sir, in my screen is not showing.
What do you see now? Do you see whiteboard now?
Yes, sir, your screen is visible.
See,
Not visible, sir.
okay, all right. See, if some of you are not able to see my screen, then it's a problem from your side. Just reconnect yourself. If all of you do not see the screen, then it's a problem from my side, and I will reconnect myself. So I think
It
right
is
now,
visible.
okay,
Now visible.
just reconnect
Sir,
yourself.
visible है.
Yes, okay, all right.
It is visible.
Sir, visible.
Okay, so mute yourself now. So this is the kind of screen you will also have on your desktop or mobile. Go to the file section. This is the main screen on your PC or mobile. Go to this file section. You will have recordings here. There is another folder, class materials here. And if you click, I have posted. This is the PDF file of my last class. Whatever I have written on this board, everything is there. Okay. So I'll keep uploading my handwritings after every class. And I have already uploaded the reading material for relativity part. So one is this PDF file, which are chapters of this book, Concept of Modern Physics. So here you have some part of relativity, the first chapter itself. Okay, so either you can follow this book or you can also follow the other book. Okay. This is the book by Relativity by Robert Resnick. If someone has a very deep interest in relativity, यदि किसी का relativity में ज़्यादा ही interest है, I suggest that read this book because this is like a story. ये कुछ आपको कहानी की तरीके से लगेगा. क्या साइंटिस्ट को प्रॉब्लम आई थी, कैसे साइंटिस्ट ने सोचा या उनके साथ डील किया, क्या क्या नए चैलेंजेस आए, जिस तरीके से रिलेटिविटी को सॉल्व किया गया है टाइम वाइज, उसी हिसाब से इस बुक को लिखा भी गया है. ओके, सो दिस बुक स्टार्ट्स फ्रॉम समवेयर अराउंड 1800 or so, 1850, and then it has everything developed so far in the relativity. Okay, so you can follow this book also. What is the role of Einstein in relativity? क्या आइंस्टीन के थॉट्स थे, क्या न्यूटन मैकेनिक्स के से दिक्कत थी आइंस्टीन को, वो सब इसमें बहुत अच्छे से एक्सप्लेन किया गया है. So you can follow any of the book. For fundamental level, you can follow any of the book. Okay. So for relativity, these two books are required. You can use any one of them. So let's come back to this topic. Relativity is all about motion or movement. Okay. If you look around you, यदि आप अपने आसपास देखें, it is not very difficult to observe whether someone is moving or not moving. ये पता करना बहुत मुश्किल नहीं है कि आपके आसपास के ऑब्जेक्ट्स मूव कर रहे हैं या रुके हुए हैं, राइट? बट इन रियलिटी इट्स ए वेरी डिफिकल्ट टास्क. In fact, it is impossible to determine whether someone is moving or not. आपको लगता होगा कि ये बहुत आसान है पता करना कि कौन चल रहा है कौन नहीं चल रहा, बट हकीकत में ये पता करना इम्पॉसिबल है कि कौन चल रहा है कौन नहीं चल रहा है. So let us consider a very simple case. It is hypothetical, but you can easily find out what are the possible outcomes here. So we have this person. Let me give some name to it. Person A. Okay. And this person is somewhere in the universe. He is not on Earth. He is not on any other planet. He is somewhere in the universe, and all the planets are very far from him. जितने planets है और जितना भी galaxy है, जितना भी सौर मंडल है, everything is very far from him. He is just in a blank universe. Okay. कैसे ये पर्सन डिटरमाइन करेगा अपनी वेलोसिटी को? द क्वेश्चन इज व्हाट इज द स्पीड और वेलोसिटी ए? सो दिस पर्सन इज नॉट ऑन अर्थ. ये कहीं ये सिर्फ एक ब्लैंक यूनिवर्स में है, एंड बट ही हैज ऑल द मशीन्स व्हिच आर अवेलेबल ऑन अर्थ. जितना भी मशीनरी टेक्निक्स टेक्नोलॉजी अर्थ पे अवेलेबल है सब इसके पास है. एंड दिस पर्सन वांट्स टू डिटरमाइन हिज ओन वेलोसिटी. Can you find out the velocity of A? Can you help this person A to find its velocity?
Sir, for that
No,
we will need a
no.
frame of reference
Okay, one
with
by one.
respect to which it is moving.
There is no reference.
There is no frame of reference in that universe.
Right. So, in fact, there is, in reality, this question itself has no meaning, right? This question is either complete or it does not have any sense. When someone asks what is the velocity of A, it does not mean that it is not moving or moving. This question itself is incomplete. ये question ही incomplete है. Okay. Let us consider second case. In this blank universe, we have this person A, and we have another person B. Okay. There is some separation between them. Let me call it S. And this separation between them is a function of time, or in simple words, S is increasing with time. Okay. Again, the first question is, what is velocity of A? What is velocity of B? Okay. Can you answer any one of the question? क्या एक ही वेलोसिटी आप पता कर सकते हैं?
No, sir, meaningless.
No, sir.
नो सर.
सर जो फंक्शन होगा उसको डिफरेंशिएट कर देंगे तो रेफरेंस मिल जा सकता है.
Sir, we can answer only one.
We
but
can
not
measure
both.
it only with reference
With
of
respect
B.
to only one person, we can measure the speed of another.
So let us say ds over dt is this number. Okay. So we have got some number. We do not know what is the meaning of this. If I ask who is moving, can you answer? इन दोनों में से कौन मूव कर रहा है?
No, sir.
No, sir.
No, sir.
No sir.
No, sir.
Obviously, someone is moving. That's why the distance between them is increasing, right?
Yes, sir.
May
तो बोथ मूव कर सकते हैं, सिंगल भी मूव कर सकता है.
What does this number be, which is ds over dt?
Relative velocity.
Relative velocity.
It is
Relative velocity.
velocity, right?
Velocity.
So yes, it is impossible to define that who is moving. In fact, who is moving is a completely meaningless thing. If you ask A, he will say that I'm not going anywhere. It is B who is moving. यदि आप A से पूछेंगे तो ये कहेगा कि मैं तो कहीं नहीं गया, B मुझसे दूर जा रहा है. It means B is moving with respect to A, right? If you ask B, what will B say? I'm not going anywhere. It is A who is moving away from me. B से पूछेंगे, B का जवाब होगा कि मैं कहीं नहीं जा रहा, A मुझसे दूर जा रहा है. और A is moving with respect to B. What is this velocity B? It is a relative velocity. B is moving with speed V with respect to A, or A is moving with speed V with respect to B, right? So in simple words, whenever we talk about velocity or speed, velocity is equal to whatever number, we also have to define that it is with respect to something. ये किसी के रेस्पेक्ट में ही हो सकती है. Unless we have this frame, unless we have someone who compare, we cannot define the velocity, right? So these two things always comes in a pair. If we write something, we have to write something here also. These two things always come in pair. Okay, if you change any one of them, other will automatically change. इसमें से कुछ भी एक आप चेंज करेंगे, दूसरा भी automatically change हो जाएगा. Let's come back to Earth. वापस अर्थ पे आते हैं. How do you, I mean, why it is so easy to see whether things are moving or not? फिर अर्थ पे ये सब इतना आसान क्यों हो जाता है?
Earth is stationary because we are standing on
The frame of
Earth
reference
and
हम लोग पहले से decide
सर
कर
हम
चुके
ग्राउंड
हैं.
को फ्रेम ऑफ रेफरेंस
Earth is considered as frame of reference.
On Earth, whenever we say that the speed of a bike is, let us say 40 km per hour, this is also with respect to, but this with respect to is so common that we do not write it. What is with respect to here?
Earth.
Ground.
Earth surface.
So here we are so used to that we do not write this sentence. It's implicitly assumed that Earth is not going anywhere. The velocity of Earth is always 0. Okay. So all these numbers which we think are absolute, जो भी numbers हम समझते हैं absolute है, ये वास्तव में Earth के respect में define किए गए हैं, right? Okay. So let us So we may have velocity v with respect to, let us say, some person A. For some other person, let us say A prime, the velocity may change. It becomes B prime. For some other person, A double prime. The velocity of the same object, let us say we have some other object B. This is the velocity of B. We can have different value depending on who is doing the measurement. एक ही ऑब्जेक्ट की डिफरेंट वेलोसिटी हो सकती है, डिपेंड करता है वेलोसिटी को मेजर करने वाला कौन है, राइट? व्हाट इज द कनेक्शन बिटवीन ऑल दिस नंबर्स? क्या इनके बीच में कोई कनेक्शन है? लेट अस से वी नो द कनेक्शन बिटवीन A and A prime. Can we find the connection between B and B prime? Obviously yes. If we know how is A connected to A prime, how is A connected to A double prime, we should be able to know what is the connection between B and B double prime, right? So these kind of connections have a particular name. Then the credit goes to the scientist who discovered these equations, and these are called Galilean transformations. Okay. What is Galilean transformation? So let us say we have a ball or some object. Let me call it E. Okay. So it's a point object. Although I have made a very big point, but consider it as a small point only. We have two observers. One is, let me call this person S, and we have another observer. Let me call this person S prime. Okay. And let us say this V is the velocity of S prime with respect to S. Means if you ask S, यदि आप S से बात करेंगे, he will say that S prime is moving with velocity. Okay. If you ask S prime क्या कहेगा? S is moving with velocity B in this direction. Okay. Now we ask from both of them about this particle P. So the first basic question is, position of this particle. Okay. So we are asking from both S and S prime, what is the position of this particle P with respect to S and S prime. S के according P का position क्या है? S prime के according P का position क्या है? So we need some coordinate system. We need something so that we can locate this point. So let us draw a coordinate system for both of them. Let us say this is the coordinate system of person S. Okay. So according to S, if something is very close to S, the x is equal to 0, y is equal to 0, z is equal to 0. यदि कोई ऑब्जेक्ट S के ही हाथ में रखा है, means this is the position of that object. If some object is placed, some object is with S prime, यदि कोई object S prime के पास है, so S prime will say that this is the position. X prime is 0, y prime is 0, z prime is 0. Okay. Or they have their own coordinate system. हर एक का अपना अपना coordinate system है. So according to S, the position of this particle P is actually this vector. Okay. Let me call it vector R. According to S, what is the position? Vector R, or in simple word, it is x along I axis, y along j axis plus z units along k axis. Okay. If you ask S prime, he will say this is the position of particle. How much it is? R prime. Okay. So they are looking at the same particle, but still their measurements are different because they are measuring with respect to themselves. वो अपने अपने respect में इसको measure कर रहे हैं. They will get different number. It is r prime or x prime I k plus y prime j k plus z prime k k, right? What is the connection between r and r prime? So let us say at some time t is equal to 0, मान लेते किसी time t is equal to 0 पर s and s prime were at the same position. किसी time t is equal to 0 पर दोनों एक ही जगह पर थे, but since according to s prime is moving, s के according s prime तो move कर रहा है. So at some later time obviously there is some distance between them. So let us say this is the scenario at some time t. ये कुछ देर के बाद की कहानी है. So how much is the distance between these two? Vt. And let me
Vt.
Ik. Okay. So this is the distance between these two. Now, what is the connection between r prime and this Vt?
Vt plus r prime is equal to r.
Right? Or in component wise, both have same meaning. You just write in a different style, nothing else. And if you divide this thing in component, x prime is equal to x minus Vt, y prime is equal to y, z prime is equal to z. And let me call it x component only. Okay. If s prime is moving in a three-dimensional space, then obviously we will have minus by, we will also have minus vz. But otherwise, this is the connection between their measurement at some time t. What is the velocity of particle p with respect to s? According to s, the position is r, right?
dr by dt.
But if you ask the velocity of particle p with respect to s prime, obviously he is measuring the distance r prime. So with respect to s prime, this must be the velocity of particle p. मान लीजिए यदि पार्टिकल p मूव कर रहा है, यदि पार्टिकल p भी मूव कर रहा हो, तो दोनों की इसकी वेलोसिटी s और s प्राइम क्या दिखाई देगी? This, right? What is dr by dt? So the x component of the velocity of this is dx over dt. Y component is dy over dt. Z component is dz over dt. Same thing for this. The x component with respect to s prime is dx prime dt. Y component is, and similarly for z component. So if you take derivative of these equations, what is dx prime over dt? Vx prime of particle p is equal to velocity of the same particle with respect to s is this much, right? So you can see, if we know the connection between the frames, यदि हमको ये पता हो कि frames के बीच क्या relative velocity है, we can also find velocity of this particle, I mean, we can establish a connection between velocity of this particle in different frame. यदि हमें फ्रेम्स के बीच का कनेक्शन पता है तो इस पार्टिकल की जो वेलोसिटीज आ रही है डिफरेंट फ्रेम्स में उसके बीच में कनेक्शन पता कर सकते हैं. These are the velocities with respect to s prime, right? And these are the velocity with respect to s, and they are connected by this formula. These relations, either x prime is equal to x minus bt or b prime is equal to v minus v, these are called Galilean transformations. Okay. Or Galilean transformations establish a connection of velocity of an object in different frame. एक ही ऑब्जेक्ट की डिफरेंट फ्रेम्स में क्या वेलोसिटी हो सकती है, उनके बीच का कनेक्शन गैलीलियन ट्रांसफॉर्मेशन से मिलता है. एनी डाउट अप टू हियर? यहाँ तक किसी को कोई डाउट है?
यस सर.
यस
सर ये जो आपने लिखा है आर वेक्टर इज इक्वल टू आर प्राइम वेक्टर प्लस वी वेक्टर टी.
यस
सर ये नहीं समझ में आया है.
just solve this triangle. How do you evaluate this r vector?
By adding both the vectors.
Yes, that's what we are doing.
And r prime.
Yes.
Okay sir, thank you.
Vector of addition.
Yes, it's a simple vector addition. Okay. If everything is going in one direction, then it is just addition of scalars. यदि सब कुछ एक ही एक्सिस के अलॉन्ग हो रहा है तब तो और सिंपल है.
Okay.
Sir, S prime has moved from S for t seconds with speed v. That is why we get vt.
Yes. So at t is equal to 0, at the start of time, s and s prime were at the same position. But as time passed, after some time t, this is the situation. Okay. And that's how s figure out that s prime is moving with a velocity v. S prime, s को कैसे पता चलेगा s prime move कर रहा है? Because the separation between them is increasing.
Okay, sir. Understood.
So these are the quite obvious and expected results. And if you try to verify, you can also verify these things. इनको verify करना भी बहुत मुश्किल नहीं है, and they come out to be true. Now let us go to the next level. What is the speed of sound? You have calculated it in your plus 2.
3 into 10 to the power
3 into 10 की power 8.
Depends on the medium.
3 into 10 to the power 8.
32 meter per second.
330.
330 meter.
Yes, something like that.
Yes sir.
30 meters per second.
When you write a speed again, you must tell what should I write now.
Sir, in air.
Vacuum.
Airs
In air.
With respect to
Yes.
Vacuum.
vacuum.
no sir, air.
How many of you are in
Vacuum में sound.
Air sir, air.
वैक्यूम में साउंड ही ट्रेवल नहीं करेगा.
आप
Sound cannot travel sir.
में sound नहीं travel करेगी.
Now let me make your statement even more precise. It's a dry air because if there is some humidity, the speed may change. And this is the speed when you realize that air is not moving. आप बाहर हैं, when you realize कि हवा move नहीं कर रही है. In that case, you will find that speed of sound is this much.
Stationary observer.
let us say this is the direction of sound. Okay, and let us say you realize that air is also moving with speed 20 meter per second. What is the speed of sound now?
350 meter per second.
Sir, 350.
350, sir.
350. 350.
This will be your outcome. If you set up any device, it will give you 350 meter per second, right? Because whatever is your measurement device, according to that device, air is also moving, right? If air is going in other direction, the same device will measure now 3 times. Okay. So this is also established. It's with respect to air. Okay. Now let us test the same thing with
Yes, sir.
and we must fill in
Sir.
this space.
Vacuum.
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 With respect to all objects, I think.
Yes, sir. With respect to all.
In any frame of reference, speed of light is c.
So any frame or object essentially means the same thing, right?
Yes, sir.
All objects of frame. Frame means someone who is measuring. Frame का
Yes.
मतलब ये कि कोई measure कर रहा है इसको. Any other answer? So when you say vacuum, you are those guys who are, I mean, whose date of birth lies in 20th century, because at a very early stage you know that light can travel in vacuum, क्योंकि आप लोगों ने सीधे पढ़ा ही यही है कि light vacuum में travel कर सकती है. But it was not very easy to assume in 19th century. 19th century या उससे पहले जाएंगे, then it was a very difficult statement to believe. क्यों? Let us come back to case of sound. Why do not sound travel in vacuum? क्यों sound vacuum में travel नहीं कर पाता है?
Sir, because it needs
Sir, it
a
requires
medium.
medium.
सर क्योंकि मीडियम की जरूरत पड़ती है.
Medium की जरूरत
Require medium.
It cannot propagate without medium.
The sound is a mechanical wave, so that's why it's required medium to travel.
Yes, sir.
So the case of sound is quite easy. The medium is the carrier of fluctuations, right? But similar things must be applied to light also. Something must be there in this universe which carry the light, right? How can something travel without any support? Like sound need support of particles. If you ask someone, a scientist of 19th century, this is a very logical question for him or her. That if something is traveling in this universe, obviously it needs a carrier. Okay. Something should be there in this universe which should help light to travel in this universe. And at that time, obviously, it was not easy to go outside the Earth. So it was very difficult to see what kind of atmosphere do we have outside the Earth. उस टाइम अर्थ के बाहर आउटर स्पेस में भी जाना पॉसिबल नहीं था. सो कोई नहीं जानता था कि बाहर किस तरह का एटमॉस्फेयर है. सो हाउ डू वी आंसर दिस प्रॉब्लम? इसको कैसे आंसर किया जाए? The very logical and look like quite genuine is this concept.
So light travel as a wave.
Sound
So
is
light
also
consists of photon. So photon sir medium बन जाता है.
सर शायद उस टाइम पे ईथर सर यूनिवर्स में ईथर को एक मीडियम माना गया था।
मान लिया था उस टाइम ईथर एक मीडियम।
Any other answer?
Sir, like throwing a ball.
Sorry, light. आप तो 20th सेंचुरी में पैदा हुए, कम से कम आज आपको पता होना चाहिए लाइट वैक्यूम में कैसे ट्रेवल करता है।
Well, corpuscle theory of light.
Sir, by oscillating magnetic and
Because it is an electromagnetic wave, oscillating magnetic field makes electric field, and oscillating electric field makes magnetic field, vice versa. So that's why it is traveling in vacuum.
So now let me answer the correct answer and the answers that were available at that time. Wave. So sound is also a wave.
Sir, particle and waves.
Sound need a medium. Sorry.
Radiation.
Okay. So wave is not a complete answer, because if something is wave does not mean that it can travel without support. Like sound is also a wave, but it needs support, right? Photon is just a different description of the same thing. Okay. So you can ask what exactly is light.
The light is an electromagnetic wave.
Ether, yes, this was the assumption at this time, and this is the correct answer. The support for electric field comes from magnetic field, and the support for magnetic field comes from electric field. So they are the carrier of each other. ये दोनों एक दूसरे को support करते रहते हैं, and that's all. This combination travel forever. So this is the correct answer, but this correct answer come at a very later stage. So I am at this point now, I mean around 19th century, when scientists believed that something is there in this universe which help light to travel. कुछ तो ऐसा है इस यूनिवर्स पे जो लाइट को हेल्प करता है ट्रेवल करने में. And what is this? So we have sun here, we have earth here, and light is coming here. So this is like you cannot visualize air, you can just have a feeling of its presence. They assume that something is there in the outer universe which is massless, or it has a extremely small mass. It has no smell. Okay. It has no density at all, and this can help the light to travel in this universe. So something invisible is there, like air, and using help of this ether, they call it ether, light is coming from sun to earth. Okay. So with respect to this ether, the speed of light is this much. Okay. It means that if you are, let us say this is the direction of light. If you travel in the direction of light, let us say with velocity v, what is this v? Velocity of some person A with respect to ether. Then what is the velocity of light with respect to A? With velocity of light with respect to A. How much it is?
C minus
C
VA.
minus VA.
Right. Let me call this number C to C minus VA. And if somebody is going opposite to this, then
C plus VA. C plus VA.
At that time, there was no dispute with the fact that Earth is moving around Sun. उस time इसमें कोई dispute नहीं था कि Earth Sun के around move कर रहा है, right? It means that we all are moving in this ether. ये भी क्लियर है कि हम इस ether में मूव कर रहे हैं. Or it simply means that the speed of light with respect to us, if our velocity with respect to ether is v, यदि हमारी velocity ether के respect में v है, then the measurement of light for us should lie between these two values. Then हमारे respect में light की speed इन दो के बीच होनी चाहिए. Agree? This is the minimum value. This is the highest value, right?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
What is v? The speed of Earth. जो भी Earth की
speed of Earth.
Yes, sir.
कितना है? कोई जानता है? What is the speed
32
of
meter per second.
30 kilometer per second approximate.
Right. So you can realize even the Earth is moving at a very high speed. You just blink your eye. आप सिर्फ एक बार पलक झपकिए, उतने में अर्थ 30 किलोमीटर चल चुकी होती है. So this is the speed, and nobody has this realization. Okay, what is b now? So b is equal to, convert it to proper numbers, 3 into 10 to the power 4 meter per second, right? So what is c minus b? 3 into 10 to the power 8 is out. We have 1 here. How much do we have here? Minus 4. Same thing here. So how much is the error? How much is the deviation in the measured result? 0.0001, right? So if someone try to measure the speed of light, they should get this much result. But at that time, it was not very easy to measure with this much accuracy. यदि आपको ये कंफर्म ही करना है कि ईथर होता है, ईथर के रेस्पेक्ट में लाइट की स्पीड ये है, then on earth the speed of light should be inaccurate by this much amount. तब अर्थ पे लाइट की स्पीड की मेजरमेंट में इतने का एरर आना चाहिए. बट इतना एरर पता करने के लिए मशीन को भी इतना प्रिसाइज होना चाहिए, राइट? And at that time, machines were not that precise. Or in other words, it was a difficult task to verify the presence of ether. उस टाइम ये बहुत बड़ा चैलेंज था कि कैसे कंफर्म किया जाए कि ईथर होता भी है या नहीं. One way is that increase B, but B is already at high speed thanks to Earth, and you cannot go beyond this speed on your own. You can take advantage of the spinning of Earth, but that is at the spinning of Earth around its own axis is not that high. It is few meters per second only, so it does not help you that much. So we need to make a device which is so accurate that it can capture such a small difference in the measurement. हमें कोई ऐसी डिवाइस बनानी पड़ेगी जो इतने छोटे डिफरेंस को भी कैप्चर कर सके. And the first successful device was this. Okay. So what is interferometer? Obviously, it is something which utilizes the phenomena of interference. Okay. Michelson is the name of scientist who developed this setup. And from that setup, they were able to get such a high level of accuracy. Right? So what is Michelson interferometer? How do they make this setup and how do they achieve such a high precision? We will discuss all these things in the next class. Do you have anything to ask now? आपको कुछ पूछना है इसमें? Anyone, any doubt?
सर एक आउट ऑफ ट्रैक का थोड़ा क्वेश्चन है जो आपने अर्थ की वो 30 किलोमीटर वाली स्पीड बताई है वो सर एक्चुअली मेजर कैसे होती है?
There may be some techniques like, I don't know, I just hit it, I just let me. So how did scientists measure that, right?
Yes, sir.
So actually you need to measure this time period around the sun, which you can measure, right? By looking at the climate and other things, or just by looking at the size of image.
Sir, it can also measure whether kinetic energy is equal to potential energy of the Earth.
No, he's asking how did this, sorry, what did you ask? This is speed, right? How was the
30
speed
किलोमीटर पर सेकंड
for the first time? पहली बार ये speed कैसे measure किया गया था?
Yes, sir. Yes, sir.
The spinning of Earth was measured by looking at the change of image at different times. जो Earth का खुद का spin है उसको measure करने का तरीका था कि कोई object Earth पर लगाइए और उसकी जो image change होती है with respect to time, that help you know the spinning of the Earth. But can we extend similar technique to measure the movement around sun? I have no idea.
और आपने जो फाइल्स भेजी हैं सर उसको कैसे एक्सेस करना है एक बार फिर से बता दीजिए.
So you please find this thing on literature. I think you can find somewhere. This is, but yes, I should also find. If I get some others, I'll tell you.
Okay. जो आपने बुक सेंड की है सर उसको कैसे एक्सेस करना है?
Okay, book. So there is a PDF file. I think you can open it easily. There is, okay. So this is another type of files. They are called DJView files. So just download any DJView reader, like PDF. Like you use Adobe Reader for PDF. There are programs for opening DJView file also. DJView Reader for Windows. You can download any one of them. This is one of the very good programs with DJView. Okay, just use this. Or if you are using mobile, I think there should be some app also.
BPS software.
Just look for some
So we can
DJView
convert
reader.
DJView to PDF.
Yes, that is also possibility. Like PDF, DJView also some sort of file extension. You just need a right program to open this. Okay. So install any suitable program which can handle DJView files and you can read it. Like I'm opening here. Good thing with DJView is that they take extremely less space. The compression is so high that file can come in a very small space. Okay. So just either convert. If somebody is able to convert, just share it with others, or you can download some program to open it. So with this, let me end this class.